Hi everyone, I am Teacher Ray, and today I'm going to teach you on how to graph quadratic function in standard form in a more convenient way. And without any further ado, let's get started.
We are two wanderers at dawn of the world full of war.
Since I am going to teach you on how to graph a quadratic function in a standard form, first let us review what is the standard form of a quadratic equation. That is y equals ax squared plus bx plus c. Again, y equals ax squared plus bx plus t is the standard form of a quadratic function. Now, the ways of graphing quadratic function is first, we must find the axis of symmetry. And then, we will find the vertex, the h and the k. And after that, we must find at least 2 points. And then, we will going to reflect it across the other side of the Cartesian plane. So let us start on giving you an example. So this is an example of graphing a quadratic function in a more convenient way. So for example, y is equal to negative 2x squared plus 4x plus 3. This is an example of a quadratic function. So from this, we have to get the values of a, b, and c. So that is a is equal to negative 2, b is equal to 4, and c is equal to 3. The a, b, c is get from our standard form of quadratic function, which is ax squared plus bx plus c. So first thing to do is, again, as I've said a while ago, we will find its axis of symmetry. Here it goes, axis of symmetry. The formula of getting the axis of symmetry is x equals negative b opposite to a. Again, the formula of axis of symmetry is x equals negative b opposite to a. And then, we will go into substitute the values of a, b, and c. So since we have here the b and the a, so the values of b and a from the original quadratic function, that is the value that we're going to use. So simply substitute, that is equals negative d, value of b is 4 over 2 times the value of a, which is negative 2. So we simplify, that is negative 4 over negative 4. Therefore, our axis of symmetry is 1. Since we already have the value of our axis of symmetry, we have to draw this one here. That is x is equal to 1 from the x-axis. So we have to draw here. So this is our axis of symmetry. That means the vertex will fall down here from the dotted or from the broken line that we draw. So after finding the axis of symmetry, we have to find its vertex. Now, since the vertex is the first coordinate of the vertex is the axis of symmetry of the quadratic function. Therefore, we have already 1 here, and we have to find the y-axis or the other coordinate of our vertex. In finding the vertex, we have here at least a convenient way to find the vertex of the quadratic function. So I have mentioned all we have to do is to use the 4x plus 3 or these 2 terms, which is from the quadratic function standard form vx plus c. So through using this equation, we will going to find the y-axis of the vertex or the other side of the vertex. So we have here 4x plus 3. We have to have or divide it 2, 2. So the x will be the axis of symmetry. So that is 4 times 1 half plus 3. That is 4 times 1 is equal to 4 over 2 plus 3. That is 2 plus 3. Then we have the value of our second coordinate of our vertex, which is 5. So from here, we have already now the vertex, which is 1, 5. So we will go into plot the 5. So from the y-axis, positive 5. So here it is. Therefore, our vertex lies on the axis of symmetry 1, and its second, the second coordinate is 5. So we already have here our vertex 1, 5. Okay, can you get it? Well, I guess so. After you get the vertex, again, as I've said a while ago, that we have to find at least 2 points to make the parabola. In finding the 2 points, we have make a table, a simple table. And again, as I've said, at least 2 points. So we have here x and y. So the equation that we're going to use is only on the first term on the side. So that is y is equal to negative 2x squared. That means we will going not to use the other two terms, which is 4x plus 3. Since a while ago we are only using this one to find the value or the other value of our, the other coordinate of our vertex. So that will be y is equal to negative 2x squared, only the first term. And then if our first value of x is 1, we have here negative 2 times 1 squared. That is negative 2 times 1, negative 2. So our value of y is negative 2. So we have here the x will determine the run and the y will determine the rise. So if we have x as 1, we will going to run at one step. So we're going to run 1. And from here, since it is negative 2, and as I've said a while ago, that negative 2 is, we will going to move downward. So that is, so we will step again 1 to this side, and then we will rise to fall. We just have to fall because it is negative 2 times. So from here, 1, 2. So this is our first point. Second point, if our x is equal to 2, so we have here y is equal to negative 2, and then we just have to substitute the value of x to 2, and then it will be negative 2 times 2 squared, that is 4. So negative 2 times 4 is equal to negative 8. Therefore, if our x is 2, our value of y is equal to negative 8. Again, we must point it here in our Cartesian plane. So again, if we will take 2 steps from the vertex, that is 1 and 2, and then since still negative 8 is a negative number and we have to fall at negative, in 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. So we already have here the 2 points. After you have the 2 points, next we will reflect it across to the other side. So it will be here and here. Right. 2 and 1, 1, 2, 3, 4, 5, 6, 7, 8. So here it is. Here is our points, and then after you make the points, you make the parabola. So starting here, and then here, and there you have it. You already make, or you already graph the quadratic function of y is equal to negative 2x squared plus 4x plus 3. Again, we must check our a here is negative. Therefore, the opening of our parabola is downward. That means that this parabola is in the maximum point. Let's take another example of quadratic function, and we will graph it in the way that I have introduced to you. Here another example of a quadratic function, that is y equals negative x squared plus 4x plus 1. We will get the values of a, b, and c. So the values of a will becomes from the quadratic term its numerical coefficient, so that will be negative 1. And the b from the second term, the linear term, which is 4, its constant term, which is 1. And then we will proceed to our first step, that is to get the axis of symmetry. So again, the formula of getting the axis of symmetry is x equals negative b opposite to a. So from the values that we get, we have to substitute the values of b and a to the formula of axis of symmetry. So that will be negative the value of b, which is 4, over or divided by 2, and the value of a, which is negative 1. And then we will simplify. Negative times 4, it will be negative 4, and 2 times negative 1, it is negative 2. So negative 4 divided by negative 2, we will have 2. So the axis of symmetry is 2. At the upper portion, we have here the Cartesian plane. So after that we get the value of axis of symmetry, which is 2, we will going to make the axis of symmetry by drawing a broken line here, and from the origin, which is the x-axis, 2, so from here, that is 1, 2. Therefore, we will gonna make the axis of symmetry at this point. That means that our vertex will lie here on the broken lines that we have drawn. And then after putting the broken line or drawing the axis of symmetry, we will going to find now the vertex. Now, as I've said, the coordinates of vertex lies here in the broken line of the axis of symmetry. Therefore, our value of our x here, or the first coordinate, will be the value of the axis of symmetry, which is 2, and here. So our task is to find the other coordinate in order for us to point the vertex of this quadratic function. Unlike the other process of graphing quadratic function, we will be able to use the whole quadratic function. But this time, the other coordinate of the vertex is coming from this, the second and third term, which is the linear term and the constant term. So that will be 4x plus 1. And remember, we must have to half it, only the linear term. So, and then we must solve this one. Our value of x is our axis of symmetry, which is 2. So that will be 4 times 2 divided by 2 plus 1. 4 times 2, that is 8 over 2 plus 1. And 8 over 2, that is 4 plus 1, 5. So our value of our second coordinate is 5. So after you get the vertex 2, 5, we will going to plot it. In the axis of symmetry, we will have to find 2 and 5. So x-axis 2, y-axis it is positive. So 1, 2, 3, 4, 5. So here, our vertex lie here at the Our vertex lie here in the axis of symmetry in the point of 2, 5. After getting the vertex, as I've said, we will going to find at least 2 points, and we will going to find at least 2 points, and then we will reflect it across. So in finding the 2 points, as I have said, we must make a table for the x and y, at least 2 points. So probably I will just choose 1 and 2. So our task is to find the values of y. Now, we'll get the value of y through using only the quadratic term of the quadratic function. So that will be y equals negative x squared. And then we will solve if our x is 1. Therefore, our value of y is negative 1. Before I forget, x determines how many times we run, and y determines how many times we rise. So to identify our rise and fall, we will rise if our value of y is positive, and we will fall if the value of y is negative. So let's try the point 1 and negative 1. From the point of the vertex, that is 2, 5, we will going to run 1 step, so 1. And since our value of y is negative, we will fall 1 time, so 1. So we have here our first point. For our next point, we have here y is equal negative x squared, same function, that is negative if our x is 2. 2 squared, that is equal to 4. Therefore, our y is negative 4. Our second point is 2 and negative 4. So from the vertex point, we will run twice, 1, 2, and since the value of our y is negative 4, so we will fall down 4 times, 1, 2, 3, and 4. Okay, and now we have 2 points. All we have to do is to reflect it to the other side. So here and here. And after which, you draw your parabola. And here you go. So that's it. So I hope that you have find some new learnings from this video, and from what I have discussed to you a while ago. Because for me, I really find it convenient because I will not be able to use all the function in order to get the tuples. At least in that way, we can minimize the time in graphing the